there you are. Hey, what took you so long? How did we get here before you?
Sorry, we were smoked.
Yeah. Oh, you smoked?
Yeah.
Bad students. All of you smoke? Even Ben?
No.
Oh, he's a good student. Okay. Good job. I thought there was a new student, wasn't there? Wasn't there a new student starting today?
I don't know.
I don't know.
Was he not?
I said health science new student.
Oh, not an engineering student?
No.
Oh, okay.
He said he's
Health science. Okay. Okay. Right. Let's continue. So. English? Somewhere?
Sorry.
Okay.
Yeah, I said maybe.
Sorry.
I was asked their opinion. I thought maybe today we can just no break and finish at 40.
Yeah.
Yeah, like, as usual.
Yeah, I think that's a good idea. Okay.
Because we have 2 classes and we move the 10-minute breaks to the last. So it's like we finish like 40.
Instead of 50.
He didn't understand. He's a little bit confused. Can I use Chinese?
No, you can't.
Yeah.
No Chinese.
If we don't have the 10 minutes rest, we can finish the class in
early 10 minutes.
Okay.
You got
See, English, no problem. No need for Chinese.
Okay.
No need for Chinese. Right.
I have an appointment later.
Oh, you do? Okay. Yeah. Okay, if you take out your notebooks, we'll continue now.
I bring somewhere by bought bag cover.
But
Because
the Casio's calculator is sold out.
Sold out?
Yeah.
So what did you get?
Yeah, it's.
I think it's like the
Oh, no. Like her one?
yeah.
Oh, that's
Oh, I think maybe it's different also.
Okay.
It's a new camera.
Okay, let's see then.
27 euro. God.
You get 12 and
12 is
I
okay.
11.
You got the best deal.
Oh.
Oh, you lost it.
No. I think it's true.
No problem.
Sorry.
That's not your calculator. That's a laptop.
Sorry.
It's a new calculator. Oh, for goodness sake, Summer, how big is your bag? Do you not find it?
Yeah, I will find that because my bag is too
Messy.
Yeah.
No problem,
You can share. Did you have it earlier today in chemistry or in maths? Did you use it today?
No.
So maybe it's at home.
I think I
I don't think so. Yeah. Okay, we'll continue anyway. So this is what we're looking at today. Projectiles, if you can write this down.
And I tutorial is which day?
I don't know which day. Maybe
Next week.
maybe tomorrow.
Tomorrow.
Yeah, because you might want to, I think you will probably want to do something from this
All
one.
of them.
Yeah, I think, I have 2 questions didn't get the answer.
Okay.
The weight, this part.
Okay. It's hard, yeah?
I think.
Between,
Yeah.
yeah. Maybe question 3 and question 2.
Yeah, I think question 2.
2 and 3. Before we did a similar one at first, so 2 and 3.
Okay, that's fine, we'll do that tomorrow. And maybe there might be something from today's lesson as well, because it's a little tricky. I don't like it. I don't like it.
Yeah, I don't like it. Because it's different from that. Yeah, and different from the Casio's calculator
Where did you buy this?
in Tesco. It's Tesco's calculator.
A Tesco calculator,
Yeah,
right?
yeah,
It's
yeah.
not Casio.
No, it's
No.
a Tesco.
It's Tesco.
So maybe it doesn't work. Let me check. 1 + 1. Oh no. Maybe it's okay. Right.
But I don't know what's this, what's that.
I'll explain to you. Don't worry. I'll explain
okay,
later.
okay,
No problem.
okay.
Okay, did you write this down? Projectiles now.
Okay. Wait.
You got your notebook somewhere?
Yeah, I have a notebook.
Okay. Projectiles.
Projectile.
Yeah.
What's mean?
I'll explain. This is a new word for you, Ben.
Yeah.
New word for everybody?
No project.
It's not that.
Singular is elastin.
Wait, what?
Elastin? Something elastin.
Oh, elastic. No, it's not similar. Nice try, though. Okay, so projectiles. Now, what exactly is a projectile? So a projectile, now don't write just yet, just listen. A projectile is an object that travels through space with only the force of gravity. No other forces except gravity, and it moves through space. Yeah, so this is a projectile. When it moves in the air, there's only one force, gravity. So we call this, that's a projectile when it is moving.
Is
Yeah.
that what force? Because you throw that.
Yeah, but when it's in the air,
Okay, during
during the movement, yeah.
It's like a line.
Yeah, a curve.
Oh, yeah.
Yeah, correct. Generally, not always, but generally, it travels along what you said, a parabolic path. That's this shape.
Yeah.
That's what that's called. Parabolic is this shape. You know this shape in maths class, quadratic. So there's a picture of it there. Okay. So I'll let you write this down, and this new word, parabolic path and projectile, are new words. Yeah, so you should write this down. Okay. To practice your English. Yeah.
Alright.
Yeah. Did you watch all the videos?
Maybe a half.
Okay, you need to watch them.
It is too long.
No, you can do it.
He say have many new word.
Yeah,
And
I have
you-
to.
you-
Maybe the videos is 25 minutes.
Yeah.
I must spend 1 hour.
Okay.
Yeah, because when I do the homework of physics,
Yeah.
I have the
Translate, yeah. But it's good. You learn new words. Yeah.
But not useful, only for exam.
Not useful for next year. If you study, you know.
Yeah, university.
Yeah.
But I don't think in college I will learn the physics.
Well, you might be surprised because, sometimes if they ask you to do a computer program,
Yeah.
they sometimes ask you to do a computer program like a little video.
Yeah, I know that.
Yeah.
Oh,
Make a little video game.
yeah.
Something like this. So your teacher could use words like this in class.
Oh.
It's never a bad thing to know many words.
Okay.
Yeah. Okay, you got this written down? Nearly, okay.
Sorry, I'm not sure I will finish all the homework because tonight I have some stuff to do.
Yeah, okay.
Maybe a
For
little bit.
Wednesday.
Yeah, I will finish it.
Okay, you got this, Ben? Yeah,
Uh,
Summer? Nearly.
1 second.
Yeah.
Maybe.
Maybe 2 seconds.
Yeah. Maybe 3 seconds.
So that new student who started today is in health science.
Yeah.
Yeah, he's African student, yeah?
African student?
No?
Maybe.
European.
Oh!
But
Okay.
his pronunciation is like African.
Oh, maybe he's from South Africa then. Yeah, okay. No, because I was told there'd be a new African student on Monday. I thought he was going to go into engineering, but he's in health science, so it's fine.
Yeah, he don't know the classroom's numbers maybe because in the morning I saw teachers.
Timetable.
Yeah.
Yeah.
Timetable.
Yeah, okay. Sharon took him to B401 in the morning. Is that where you were this morning?
Yeah.
Yeah, okay. Right, so this is a projectile. So as you said, as you were saying, there's only a force here. But once you're in the air, the only force is gravity. Okay, so this is an example of a projectile. Yeah?
Yeah.
Okay, now, this is a projectile. So once the bicycle, leaves the ground, there's no control. The only force is gravity. Now, true, there's sometimes drag, air friction, but yeah, we don't usually care about that because it's quite small. Now, it will travel along a parabolic path, as shown. Okay, look, why is this not a projectile?
Because he flies like
True, yeah. He's not a projectile because he travels where he wants. Okay, so the key thing about a projectile is you don't really have control. It just is in motion. Okay. Right. So, some things about projectile motion. The first thing is that the dimensions are independent. So what does that mean? The dimensions are independent. Let me draw. So, if this is moving like this, you can see that it has, let me draw it here. That's the, if you think of it like this, that's the x part, okay? The movement here has no effect on the movement here. These two are independent. They have no effect on each other. Now that might seem a little bit strange, but it's true. I can give you kind of a simple example. You're standing here, okay? How fast must you move left and right so that you will be here?
It's
Not possible.
no possible.
Not possible. And this is what I mean. The x and the y, they have no effect on each other. Do you understand what I mean? They're independent, okay? So the first rule is that the dimensions are independent. So you should write this down.
What is dimension?
Ben will tell you what dimension is. Won't you, Ben?
Dimension like something like F, V, T.
Yeah. And in this case, x, y.
Oh,
Yeah.
yeah. Okay.
And union like Newton.
Yeah. Now in this case, what's the unit?
Yeah.
What's the unit here? Meter and meter.
Meter per second.
Oh no, just the x and the y.
Oh.
Meter and meter.
Meter.
Yeah. Like if he's standing here,
Oh.
this distance is in meters and this distance is in meters.
Oh.
Yeah? Okay. So they're independent. Yeah? Right, next rule. Gravity acts in the y-axis only. So gravity is only this way. Obviously.
Did you say Superman?
No, I didn't actually. I didn't. I have a telescope too,
What's
but it's so cold.
But this morning the sky looks like pink.
Yeah,
in
yeah,
the
yeah, yeah.
daytime.
It's the supermoon.
In today, I think 4:30 to 5:30 a.m. They have supermoon, like blood moon.
Red moon.
Ah,
Yeah.
right. Oh.
This morning, yeah.
You get up so early.
No. I didn't. No, I just watched the news.
Oh, you just saw it on the news. Okay.
Today?
Yeah.
Didn't.
You didn't wake up at 4:30.
No.
No. Okay, so you have this one. Next is that there's no acceleration in the x. So only in the y there's acceleration. No acceleration here.
Acceleration means.
Ah, yeah, what's acceleration?
A.
Correct, A. Yeah, do you want to give him some more?
Is speed like speed or?
Yeah, what would you say acceleration is?
Sounds good.
Ah, no. I shall hit your hand if you do that again. What's acceleration? What would you say?
It's like
M per S cube. No.
Squared.
Squared.
Meters per second squared.
Meter.
Like this.
Yeah.
That's acceleration.
Yes,
Yeah.
A.
That's A. Yes, correct. Now, you can use vectors to resolve into x and y. So you learned how to do this one in class. I'll just quickly remind you. Here's our vector, okay? And let's say this is theta, and let's say this is v. And I would like to know this part and this part.
Yeah.
So what's this part?
Cosine.
Very good. V cos.
V cos.
And this one?
V sine.
V sine. Okay, so the verb is resolve is the verb. To change this into 2. Yeah, that's the verb. So vectors can be used to resolve into x and y.
Mm.
Okay, you got that?
2 seconds.
2 seconds. I'll tell you what, I'll give you 5.
1, 2.
5's not enough, huh?
Components.
Component, yeah.
What was?
These are called, this is x component, y component.
Okay.
Yeah.
Okay.
Right. Projectiles have no vertical speed at their maximum heights. So when this is moving in the air, okay, here it has an x and a y, here it has an x and a y, here it has an x and a y, but at the top it has only x and no y, and then when it passes the top it has an x and a negative y, an x and a negative y, and an x and a negative y. These are meters per second.
So
Yeah?
why the top don't have the gravity?
Gravity. Maybe.
No, these arrows are speed. Speed. So this, like maybe this is whatever, 7 meters per second, but there's 0 meters per second vertically. Yeah. No, it still has gravity. Like there's still weight. Yeah. That's still there.
So something like this, when the sample always in the peak, so it's always no speed for while it's
Yeah. Always no speed in the y at the peak at the top. Yeah. So no vertical speed at their maximum. Okay. I don't know if there's many more. Oh yeah, yeah, this last one again. Remember, S is position, not distance, okay? It's displacement, not distance. So the last point is worth restating. For example, a ball that is kicked along a field will have Sy equals 0 at the end of flight. Let me show you. So, look here. Here's the ground. Here's the ball. And then here I'll put the axis here. It moves along here and lands here. So, for example, when the ball is here, this is Sx and this is Sy. When the ball is here, the Sy is 0. Yeah? And the Sx is this distance here. There's a special name for that. It's called the range. That's the name for the maximum Sx. Yeah. So, range, yeah. So you might want to write that word down. So that's at the end, really. Well, it's on level ground, I suppose. Okay, yeah.
So there are only movement.
Say again?
Displacement. X.
Only displacement, yeah. Yeah. Okay. And by the way, another bit of vocabulary. So the time it takes to go from here to here, this is called the time of flight. That's the time to go from, say, A here to B here. That's called the time of flight. Kind of like, on an airplane, the flight time, the time from takeoff to landing. Yeah? Yeah, okay. Right, so here's our first question. A projectile is fired at 30 degrees with a speed of 100. What is the time of flight, the range, and the maximum height? So let's draw that first. Okay, so here's the ground. It's fired at 100 meters per second, and that's 30. Okay, so the first thing we should do is get this and this. So this is 100 cos 30, and this one here is 100 sine 30. Okay, do you have your calculators? You all do. Let's get each of these. So this one's 50, is it?
Yeah, 50.
Yeah, 50. And it's 50 root 3. Oh, you want? Okay, you want.
Yeah, please.
18.6
meters per second. Okay, so that's the x and that's the y. Okay. First question: what is the time of flight? Okay. So for these problems, you can look either in x or you could look either in y. So if we want the time to go from here to here, it's actually best to look at the y. So it'll increase, stop, and then come back down, the y part. Yeah. So if you look at just the y, U, V, A, T, S. What's the U? That is 50. V we don't know. A is minus 9.81. T we don't know. And S we do know.
50.
No.
18.
0.
No. What?
0.
Yeah, 0.
Oh yeah.
because it goes
Yeah,
up
yeah.
and down. Yeah.
Yeah.
Yeah, so how can we get the t? We can say S equals ut plus a half a t squared. So cancel, cancel. We get t is 50 over 4.905, and that equals
10.2.
10.19.
yeah, so 10.2 then. Yeah. Okay?
Yeah.
The next part is what's the range. So remember, the range means from here to here,
Yeah.
that distance. Now, remember we said there's no acceleration in the x. So for x, you just have to use distance, speed, time. There's no acceleration. So the speed is 86.6. The time is 10.2. And the distance is what we want, the range. So range is 86.6 multiply 10.2. Yeah, so what's that now?
818.3.
Yeah. Is that okay so far? Yeah. And the last part is, what is the maximum height? So that's this height. Okay. So should I look at x or y?
Y.
Y, yeah. U is 50. V, 0. A, minus 9.81. T, we don't know, although it actually would be half of this, yeah. And S is what we want.
Yeah.
So what should we use? We could use S. S equals ut? No. We could use v squared equals u squared plus 2as. So S is 250 divided by 19.62. So 12.8.
74.
12.7. Yeah? Okay. Okay. Can you write this one down? It had 3 parts. Part 1 was this part. Part 2 was the range. And then part 3 was the height.
I want first write
The question? Yeah. Let me show you the question. Here it was.
So the time will be half.
In this picture, yeah.
Okay.
Not always. Not always. Can you think of when the time wouldn't be half?
Won't be.
Yeah. When would that happen?
Just not in the peak.
In the pin?
Peak. In the maximum height.
No. My question is the time to the maximum height, the peak. When is it not half the total time? The time of flight. You think it always is.
maybe different area higher.
Different? No, a different area. So one example is if the ball goes up a hill,
Yeah.
then the time to here is not half the time to here.
Because the speed is different.
Well, no, because if the ball is going up a hill, not on the ground. See here, the time to here is half to here.
Yeah,
Half
but
of
the
this
speed.
is not always.
Yeah, so for this it's always, but for this it's not. The
Okay.
time to here is not half to here.
Okay.
It's less.
Okay.
Yeah.
Yeah.
And then here it's
More.
more.
Okay.
Yeah.
It's only the ground.
It's only on level ground.
Maybe it's different. The range is too long, and the first part of the time is more than the last
It-
part.
In real life,
Yeah.
because of the air,
Yeah.
yeah, but that's difficult. That's difficult.
So we don't how to say, think about air.
Yeah. Don't think about it.
I put in one question to make you think about air. Just one. Just to make it interesting.
Interesting.
Yeah, interesting.
I will lose my hair.
No. No.
Yeah. I think in high school when I started physics, I lost all time.
You think so?
Yeah.
But I'm already interested in physics if compared with high school. 'Cause the Chinese teacher, 'cause my high school was a private school, so the physics.
Is that good or bad? Bad.
And the teacher is only care about students who are smart, who can understand his question. And he only asks the person who can answer his question, and he don't care about the person who feel confused. Like it's not fair.
How many students in the class?
50,
50 or 60.
and the only 2
12.
or 3 person can understand his question.
Yeah. But now only 3.
Yeah, that's why.
Much better. Okay, did you write this down, Ben? Yeah. Now, do you have this?
It's 20 tons.
Haha.
20 tons number.
20 tons. What do you?
I mean, yeah, just 3.
Oh yeah, 20 times. Yeah. One. Yeah. It's 20 times smaller, isn't it? Yeah. You have this all written down?
Yeah.
Yeah.
But even though, have the students like me, if I ask the question, the teacher won't answer me, and the teacher will let the smart student to go to in front of, so the students can practice again, but I still don't understand what the students say.
Yeah.
That's
Sounds like it's easy to be a teacher in China.
they can make more money because that's illegal to have actual class.
Is it?
No, I mean the actual class is out of the school and they got more money.
Yeah. Maybe.
Legal or illegal?
Illegal.
Really?
They will move out what should we learn during the class. They move the important part in the actual class, and they will told us if you don't go to actual class, you will fail the exam. And in the actual class, they will get like per hour have 500 RMB. That's more.
Sneaky.
Yeah, really sneaky. That's
Sneaky.
really there.
Yeah. What's 500 RMB? It's like 50 euros?
Maybe more than 50.
Really?
Yeah.
Mm-hmm.
It's nearly 100
Is it
euro,
really?
maybe 70 or 1,700 euro per hour.
Tough. Not good.
Really tough.
Yeah.
Not good. Okay, how are you doing, Ben? Have you got this?
I have lost.
Last part? Okay. Have you studied this before, projectiles?
Yeah.
Yeah.
I remember a lot of equation. But
Yep.
Okay.
Yep, correct. Lots of calculations for this one. Yeah. Okay. Nearly done, Ben?
Okay.
Yes? Okay, good, right. Next one now. Okay. A girl throws a small stone at the side of an apartment block which is 25 meters away from her. So let's draw this. Right, so here's the ground. Here's the apartment. Okay, so she's here. Sorry.
Can I say the question again?
Yeah, 1 second. 25 meters here, I think. She throws the ball at a speed of 25 and an angle of 60 to the ground. The stone leaves her hand at a height of 1 meter. So here, this distance here is 1 meter. Okay. and she throws it at 25 meters per second, and the angle is 60. So you know it has a horizontal and a vertical. Okay, so it goes along and hits the building here. Yeah, okay, so I have two questions. One, what's the time of flight? And two, what is the height here? Now, I think you could maybe try this, yeah?
Yeah.
Maximum height?
No, the first part is the time, and the second part is this height.
Oh, okay.
Do you have the time? You have this time first?
Is 21.7 over 4.90 is 4.42.
Okay, let's calculate. So firstly, should I look at x or y?
Sorry. It's a whole range. It's not the.
Oh yeah, not this time.
Yeah.
Yeah, I want this time to here. So should I look at x or y?
What?
No, this time actually x.
Okay.
Because you know the distance, it's 25. You know the speed, it's 25 cos 60. What's that, Ben? 25 cos 12.5. Oh yeah, of course, 12.5. And you want the time.
Yeah.
So the time is 25 over 12.5 is 2 seconds. What's wrong, Ben?
Yeah.
What happened?
Oh, it's no.
Oh, it's very easy.
Very easy.
X is very easy, but Y maybe you think more, but it's okay.
Yeah, it's okay, but
I
x is easier.
I looked Y and I list all of them, but I find it's wrong. I come back to X and I think about how to calculate, but it's easy.
Much easy, huh?
Yeah.
Is that okay?
Yeah.
Go.
Two.
2, yeah.
Oh, it's too easy.
Too easy.
Yeah.
Okay, part 2, the height.
Okay.
So the height, I must look at y. I must. So, U, V, A, T, S. So the U is, what's 25 sine 30, please? What's that? 25 sine 30?
Is
21.7.
Okay, the V we don't know, the A is minus
Yeah.
9.81, the T we don't know, we do know, 2. So the S will be U T plus a half A T squared.
Yeah.
What's that?
Okay.
Yeah, yeah.
Sorry, what is 21?
23.
That's the 25 sine 30.
23. It's
Vertical.
Is y lines speed. Is y line speed.
Okay.
Yeah.
In the y lines.
Resolve.
Yeah.
What's wrong, Gav? 25 sine 30, 25 cos 30.
Yeah.
Oh, sorry.
It's right.
No, it's not right.
Science.
60.
Oh yeah.
Yeah, now it's right.
But
Sorry.
we calculate.
But you calculate
Yeah,
sine
yeah,
60.
yeah.
Thank you. Okay. What's the S?
It's 23.78.
So 8 then.
Yeah.
23. Yeah.
Is that the answer?
Yeah.
No. H is 24.8.
Act
one.
one.
Yeah.
Add the 1.
Add 1.
Yeah.
Yeah.
Yes.
Easy.
So, so what time we watched Y and what time we watched X?
Both the same time to here.
No, I mean, because last question we were asking.
Oh, it depends on your information. You know, the reason I use X here is because I knew both the distance and the speed.
Yeah.
Whereas the last example,
What's the last question?
1 sec, to get the time, I had to use Y because I knew these three. I didn't know what this was.
Yeah.
If I knew this, and I knew this, 100 and the 30, then it's easier to get the time using X.
Okay.
But it's only because I knew the range.
Okay.
Yeah, more information.
Yeah.
Is there more to this? No, that's the 2 parts for this one.
Okay.
Yeah. Can you get the 2 seconds using only Y, or must you use X? I think only X is possible, isn't it?
Because Y, we just have two.
2 information pieces of
U
information.
and A.
U and A. Yeah. So it's not possible. Yeah.
Let's wait. We will have H next question.
You would need to have H. Yeah.
Okay.
UI.
Or V. You know, if I asked you for the maximum height. Yeah. Okay.
Yeah.
Let's continue then. So, what's wrong?
Why we can't use the 2 meters per speed?
2 meters.
Yeah. Why we can't use the 2 set
You can.
in the in the y line?
We can. We did, didn't we? That's it there.
Yeah.
Okay.
But you said.
Oh no! For part 1,
Oh yeah.
for getting the time,
Oh yeah.
you must use X.
Yeah.
Okay. Thelma and Louise drive their car off the side of a cliff at the end of the movie. The cliff was 400 meters high and the car was going at 36. So let's draw the picture here. So you have a cliff. What?
I don't understand the question meaning.
Okay. Thelma and Louise. They're
Yes.
people's names.
Oh.
Because they look big L, big T.
Oh,
Yeah.
okay. Oh, drive there.
Drive their car off the side of a cliff.
Cliff.
Cliff. Like
Oh.
Yeah.
by the seaside,
Oh.
by the ocean.
Yeah.
The cliff was 400 meters high.
Oh.
I think the last time you should let us to draw that picture along.
Practice.
Yeah, it's difficult to understand.
Don't worry, you have lots here to practice.
Oh.
Right, so the car is here, okay, and it's going at 36 meters per second.
Yeah.
So it's coming along and then it goes down like that.
Yeah.
My first question is what's the time of flight? So let's do this together, the time of flight. So should I look at X or should I look at Y?
One.
I should look at y. Okay. U, V, A, T, S. Right, what's the U?
36.
Oh, say
Minus 36.
No.
Nope.
What?
We don't know the angle.
Ah, you do.
it's
It's a car on a road.
it's for 45.
90?
No?
It's a car.
What's the U? Zero.
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 Right.
Just, you know, look at the picture. So here's the car, okay? The angle, 0 degrees. It's going straight. There is no vertical.
Oh.
There's only horizontal. Yeah, so there's no y. There's only x.
Yeah.
So the u is 0.
Oh.
Yes.
And the way is
Yeah.
36.
No, v's not 36. We don't know the v.
36 is for x, isn't it?
Oh,
It's for the x, yeah. The a we know.
yes.
The t we don't know. And the s,
Minus 4.
minus 400. Can you get the t and the v?
Yeah.
You can. So the first two question is, well, the first one's what the t. So I'll let you tell me what the t is. So part one is what's the t.
Four.
4, is it? Are you sure?
Are you sure? What's quick?
It's 9.
9. That's different to 4.
Yeah, it's different.
It's quite different. Who's right? Ben, decide who's right.
I don't know. Choose what?
What equation?
Yeah.
S equals ut plus a half at squared. S equals ut
Okay.
plus a half a t squared.
Oh, yeah. Yeah.
So,
it's right, it's
The
right.
t is the square root of 400 over
over
9? Exact?
No. It's
No, 9.05.
9.05 seconds.
It's
9.03.
81.5. 81.
Square root. Root.
Oh.
You didn't root.
Yeah.
9.03.
Yeah.
No, it's not.
Yes. Okay. Part 2. What is the range? So I should now look at x.
Is 9.
Range, distance. What's the speed?
36.
And 9.03. So
325.08.
okay, so 325 meters.
Yeah.
Okay. What was the velocity of the car at impact? So velocity, I want both the x and the y. Now actually, you know the x already.
Yeah.
It must be 36 because this x doesn't change.
Yeah.
So only the y changes.
Yeah.
So I need to get the v here. So the easiest way is just to say v equals u plus at. Yeah, so minus 9.81 times 9.03.
Just
What?
the 80.
Vy equals u plus at for this one. And the u is 0 in the y.
Is
Yeah,
not
okay.
minus way
Yes,
equals
minus.
a UST? Oh, yeah.
Yeah.
Minus
Minus 88.5584.
So 88.6
Yeah.
meters per second.
Yeah.
Okay? So the last part is what is the speed of the car at impact? Yeah.
13?
No, this part's 36.
What was the
And this part is 88.6. And I want the speed.
result?
Not resolve, the opposite, resultant.
Oh, result.
resultant, yeah. So the speed is square root 36 squared plus 88.6 squared. Yeah.
But it's difficult to. If I do that question alone, I won't know
Is,
the speed is
90
equal result.
Now you should know. What is it?
95.6
Meters per second.
And
So what's happening is when it hits the water, it's going this way with 36, it's going this way with 88.6. So in total, the total is it will hit the water at 95.6.
Yeah.
And you could even calculate this angle if you wanted.
Yeah.
That angle would be tan inverse 88.6 over 36. So what's that?
six,
7.8. No.
9.
Degrees.
Yeah.
Down. Yeah. Interesting. Yeah. Yeah. Okay, let's have so there was just that one there. No, don't worry. Let's see. Yeah, we'll practice a couple before continuing.
Page 24.
Today we will
Yeah.
two lessons.
Yeah.
Two class. Two lessons.
Yeah. I just want you to practice. So, of course, you should finish at home, but just practice question 1 now. Just do question 1.
Okay.
Well, what's the horizon?
Horizontal,
King?
vertical.
Oh, yeah.
Math.
Speed. It's go down or go up? Go up.
Goes up.
Fair.
Fired. Like normal.
Oh, yeah.
Like my first
Fire.
example.
Fire the home.
Fire in the hole. Oh, yeah.
Fire in the hole.
Yeah,
Correct.
yeah,
Yes.
yeah.
Yes.